In this problem, we're asked to find the time that a projectile fired 20.4 meters away from a cliff, which lands on top of the cliff, is in the air for. The main idea is using kinematic equations. To solve for this time, there are two equivalent approaches that we'll look at in this problem. The first is to solve for the time it takes the projectile to move 20.4 meters horizontally, and the second is to find the time it takes for the projectile to travel h meters vertically. We'll see that these two approaches will both give us the exact same answer. We'll first solve for the time it takes the projectile to travel 20.4 meters horizontally, a distance which I've labeled x in this diagram. From the kinematic equations derived in Part A, we know that the x velocity of the projectile is equal to its initial x velocity always. The initial x velocity is equal to the x component of the velocity with which the projectile is fired at minus the velocity of the cart, which is written right here in this equation. We can then use the second kinematic equation we derived in the x direction in Part A to solve for the time. Setting x naught as 0, the time it takes for the projectile to travel a distance x is equal to that distance divided by the velocity, where we substituted in this expression for v naught x that we just found. The second approach to find the amount of time that the projectile is in the air for is a two-step process. First, we find the y velocity when the projectile is a distance h units above the ground. We use a kinematic equation that we derived in Part A and substitute in the initial y velocity, which is equal to the velocity that the projectile is fired with times sine, and we substitute in negative 2gh for this expression here. Plugging in values, we find that the y velocity when the projectile is at the top of the cliff is equal to 0, so that's the highest point in its trajectory. The second step, now knowing what the velocity is to solve for the amount of time it takes for the projectile to go from its initial velocity to 0. We set Vy equal to 0 and solve for t to get this expression here for the amount of time the projectile is in the air. All that's left now is to evaluate the two expressions that we found. Plugging in the values from the problem statement, we see that both approaches give us a time of 1.43 seconds for the amount of time the projectile is in the air.